Hey there, Angela here, and we're going to be going over the relationship between the Earth and the Sun. Now, what does that really mean? Does it mean they hang out? Does it mean they talk? Do they do coffee? Well, yeah, they kind of do. And not only that, but they have four really significant dates throughout our year that they do this. So, we're going to talk a little bit about how these two really, really important aspects of life for us communicate and interact with one another, and how they make it possible for us to be here, and how they make it possible for us to be successful and have the life that we do. So, we're going to be learning about the Earth's rotation, its revolution, and the importance of the tilt of the Earth, and what we call the annual march of the seasons. We're going to also talk about those special lines of latitude. Man, latitude is important, isn't it? The relationship with the solstices and the equinoxes. Talk about the relationship between the angle of incidence and radiation intensity, which means the strength of the sun. We're going to talk about the vertical, oblique, and tangent rays. Not everywhere on Earth receives the same amount of the sun's energy. So when that happens, we have to them, name it with either vertical, oblique, or tangent rays, depending on where you live in the Earth. We all get different angles of the sun's solar radiation. And then we're going to talk about day length, how day length and how long the sun is out affects our weather and locations on Earth during different times of the year. So, the Earth's annual revolution, so the amount of time that the Earth goes around the sun influences the angle of solar rays. So, this also means that the amount of time that we have day, and day is signified by the amount of time that the sun is out, right? Night is signified by the amount of time that the sun is not out when it's dark. And we call the Earth's energy solar radiation. This solar radiation is also called insolation. You're going to see this word sol, S O L, here in solar radiation. You're also going to see it here in insolation, S O L. Remember, this is a Latin derivative for the word sun. And in Spanish, what is the word for sun? Sol, S O L. So when we talk about insolation, this means the amount of energy that each location on Earth receives of the sun's energy. And it's different. It's different everywhere on Earth. So we're going to study this relationship between how the Earth and the sun hang out and how they interact. The first way this happens is the Earth's rotation. So not only do we travel, right, around the sun, every day the Earth also rotates on its axis every 24 hours. So each rotation can be seen in the daily change from day to night. Now, why does the Earth rotate? It will help to understand how our solar system was formed. So, 5 billion years ago, our solar system had its beginning as a vast cloud of dust and gas. And this cloud, it collapsed and it turned into a giant disk and it began to rotate just as an ice skater spins faster. And all of a sudden, it pulled itself in. The sun formed at the center, and the swirling gas and dust in the rest of this disk clumped together, and became the planets, the moons, many asteroids, and comets. So the reason so many objects orbit the sun is nearly the same in the direction how they formed in this disk. So everything formed around the sun. While these planets were forming, clumps of matter of all sizes collided, and they either stuck together, they sideswiped, they bounced into each other, and they sent each other spinning. Now, our Earth was one of those places, one of those planets that was created from what we call the Big Bang, right? Here is our Earth. And our Earth is actually, you'll notice, it is not orientated straight up and down. It's actually tilted. It's actually tilted. So here's North America over here. Here's California on this side, Oregon and Washington. Our Earth is tilted. Here is this imaginary axis that our Earth actually spins on. The Earth revolves around the sun every 365 and a quarter days. And this we consider to be 1 year. This orbit is not a perfect circle, and I'm going to show you this in a minute. Our orbit is actually the shape of an ellipse. You'll see that down in just a minute. Because the Earth travels in an ellipse, it sometimes is closer to the sun and sometimes it's farther away from the sun. So here is how we travel around the sun. Like I said, it's not a perfect orbit around the sun. It's actually an ellipse. So sometimes we are farther away from the sun, as here. And in this example here, we're closer to the sun. Interestingly enough, in the northern hemisphere, we actually, when we're closest to the sun, have winter. And in the northern hemisphere, when we are farthest away from the sun, is actually when we have our summer. You're going to say to yourself, well, how is that possible? It's possible because of the tilt of the earth. Does not have to do with the distance we are away from the sun. It has to do with the fact, as you can see here, look at this planet Earth. Do you see how the northern hemisphere on this side is tilted away from the sun? Now look over here. During aphelion, when we're farthest away from the sun, notice that the Earth here, the northern hemisphere, is actually pointing toward the sun. So it's the tilt of the Earth that causes this. You will notice here in figure B, we call the time when we are, as the Earth, in a relationship to the sun, when we are nearest to the sun, it's called perihelion. And when we're farthest away from the sun, it's actually called aphelion. The farthest point from the sun is July 4th. We are closest to the sun on January 3rd, and we call that perihelion. So you'll notice this is how the Earth is orientated. See how the northern hemisphere points toward the sun during aphelion, even though we're farthest away from the sun. Interesting. Here is another image that shows that. So the tilt is one of the big reasons for why we experience life on Earth as we do. Our Earth's axis is tilted at 23.5 degrees. And isn't it interesting that two of the world's most important lines of latitude are also 23.5 degrees? What are those important lines of latitude? The Tropic of Capricorn at 23.5 degrees south and the Tropic of Cancer at 23.5 degrees north. While the Earth axis is pointing toward Polaris, which is the North Star, you can see in figure 3.3 that sometimes the North Pole is oriented toward the sun, and sometimes it is not. The phenomenon that influences daylight, we know this as day length. All locations on Earth have varied amounts of day length. The farthest away you get from the equator, you're going to have a bigger range between sometimes in winter, you're going to have very little day length, but then in the summer, you're going to have very long day length. The closer you live to the equator, which means equal, means that you will have more days throughout the year that have the same amount of day length. So at the equator, they have the same amount of day length all throughout the year. 12 hours of day and 12 hours of night. And like I said, the farther away you get from the equator, the more varied your day length will become. So as we see in figure C here, the reason for the seasons is the tilt of the Earth's axis at 23.5 degrees. Now, where did this idea come to have 4 seasons? Not everyone experiences 4 seasons. The 4-season year is really typical in the mid-latitudes. Where are the mid-latitudes? The mid-latitudes are between 34 degrees north and south to 60 degrees north and south. Think of places on the earth like cities or states that are located between those latitudes. So, for example, you're talking about San Francisco, Portland, Oregon, Seattle, New York, Chicago. You're also talking about a lot of places in Europe. The farther north you go, the bigger difference in the seasons. So this means that in cities like New York and London, they have 4 seasons. Places near the equator have little seasonal variation because they have the same amount of daylight and darkness throughout the year. So near the equator, regions usually only have 2 seasons, rainy and dry. Take, for example, a place like India. They, according to the Hindi calendar, have 6 seasons. Ritu means seasons in Hindi. So they have spring, summer, rainy, autumn, pre-winter, and winter. So this idea of having 4 seasons is a very European-based idea. If you go to Hawaii, they don't have 4 seasons. The reason why we came up with the 4 seasons has to do with 4 very important dates between the sun and the earth, and we'll talk about those in just a minute. The shape of the earth is one big important factor in the relationship between the sun and the earth, because the surface of the earth is curved. So this means that the sun's rays are going to strike differently in different parts of the world. This is one of the reasons why it's so important to learn about latitude and longitude. When it comes to latitude, it depends on where you live. Latitude means that every place on Earth, according to latitude, is going to have a different, what we call, angle of incidence. This means that the angle that you live at, remember the degrees, we talk about latitude in terms of degrees because it's an angle, is going to vary based on how much of the sun's rays you're going to receive. For example, Figure D outlines solar radiation in the northern hemisphere in June. So here is the angle of incidence. So depending on your latitude, now this is based on the northern hemisphere. Remember how I showed you up here in this figure? In the northern hemisphere summer, the earth is tilted toward the sun. So this means that our angle of incidence, so the angle that of the amount of sun that is coming in to the northern hemisphere is more direct. The sun's rays are more direct. This means that in the northern hemisphere, the sun's rays are going to be more direct, more concentrated. And what else? We have longer days. So it means that the sun's rays are more direct, also means that the sun is out longer. Now, during the northern hemisphere winter, the sun's rays, remember, we are pointed away from the sun. So that means we receive a lower angle. So the sun's rays are not as strong. This angle is reduced. The other thing is in winter, our amount of day is shorter. So not only do we have less sun that's out throughout the day, it's also at a lower angle. It's not as strong. Here is another figure, figure 3.4, that shows the angle of incidence, the angle of the sun's rays that we receive. What we're showing here is a northern hemisphere winter. Here we're showing this is going to be a southern hemisphere summer because we have the highest amount of sun being directed along the Tropic of Capricorn, which is 23.5 degrees south. The sun's vertical rays strike the equator and the equator, remember, is 0 degrees on the March equinox, which is about March 20th, and the September equinox, which is about December 21st. So we have these four very, very important dates throughout the year where it's kind of like where the earth and the sun kind of have meetings or they meet up. Two of them we call an equinox. So we have a March equinox and we have a September equinox. What are you hearing in the word equinox? It's the word equal, like equator. This means that during the March equinox and the September equinox, everywhere on the earth receives 12 hours of day length. During the equinoxes, the circle of illumination, which is what you're seeing here, see this half circle where half of the earth is all lit up, creates an equal amount of day length for all latitudes. Equinox means equal. So during the March and fall equinox, all places on earth receive equal amounts of sun. The other two important days where the sun and the earth meet up are called solstice. Again, we're hearing the word sol, which means sun. Now, solstice are a little bit different than an equinox. A solstice, the relationship is when one hemisphere is going to have its longest day and the other hemisphere is going to have its shortest day. So you'll notice here for the June solstice, in North America, this is when we are pointing toward the sun. And this is when we are going to have, in the northern hemisphere, our longest day. This means the sun is going to be out for the longest amount of time. This is a fun day because we wait all year. And you will notice that the sun rises and sets at the longest amount of time. Now, if you live near the equator, it's still going to be pretty much the same. Like I said, the farther away you get from the equator, you're going to have differences, higher differences between your day and your night. So during the June solstice, everywhere above the Arctic Circle is going to have 6 months of day. Wow. Anywhere above this, it's going to be day. Unfortunately, the June solstice for the southern hemisphere means that they are going to have 6 months of night. So it gets very, very dark. Now, in the December solstice, for us in the northern hemisphere, it's the opposite. It's our winter. We're pointed away from the sun, and we have less of a day length. So the sun is out for fewer hours. So everywhere around the Tropic of Cancer, we're going to have a longer nighttime than we are a daytime. Now, in the southern hemisphere, this is their summer. So in Australia, when it's Christmas, it's hot. In New Zealand, it's hot. And the same happens here. Down in the South Pole, they will be receiving 6 months of day, where above the Arctic Circle, in the northern parts, they will be receiving 24 hours of darkness. Here you will see in figure F, this diagram shows you the June solstice. This is the longest day of the year for the northern hemisphere, the shortest day of the year for the southern hemisphere. The sun's rays will be directly overhead at the Tropic of Cancer, which is 23.5 degrees north. So this means that this is when we are pointed toward the sun and we're receiving the most direct sun as possible, and the sun is out for a longer amount of time. Here is a diagram, figure G, that is showing the December solstice. The sun's most direct rays are going to be at the Tropic of Capricorn down in the southern hemisphere. We are going to have a longer night, and we are pointed away from the sun, and we receive an angle of incidence that's low, which means the solar radiation we receive is a lot less concentrated. Now, down on this figure 3.8, you're going to be labeling in your lab the difference between an angle of incidence, or an angle that the sun's rays are going to be hitting the sun. We call those, it's either a vertical sun ray, oblique, or tangent. And here is an example that's done for you. And here are the instructions. Rays that strike the earth at 90 degrees are known as vertical. Rays that strike the earth at an angle of less than 90 are known as oblique. And rays that strike the earth at 0 degrees are known as tangent rays. So this is very, very important, because in different parts of the earth, we can grow different things. How many times have you ever received a fruit from in and around the Arctic Circle? Do you think there's a reason for that? What sort of the sun's energy do they receive? Do they ever receive direct sun? No, they don't. So it's important to understand that certain parts of the earth, like for example the equator and in between the tropics, this part of the earth is going to receive the highest concentration of sun. Think about all the fruits that we get from this part of the world. Think about coffee, right? This is where coffee comes from, bananas, anything else? An enormous amount of fruit. Where are the world's most populated regions in terms of plants and animals? It's all within this zone. And there's a reason for that. So, as we've just learned, vertical rays are those that strike the earth at 90 degrees. Those are the most direct. Therefore, the latitudes on earth that receive vertical rays will receive the most intense insolation. The latitude of the sun's vertical rays is called a declination of the sun. This is where the sun's rays are most direct. The sun's rays can only be directly overhead between the tropics. And I guess that's why we like going to those places for vacation. Because, as I've said before, those areas really do not receive 4 seasons, they receive 2. And the other thing is, for when we're in winter and it's cold, we know that we can go to certain parts of the earth that are going to have the same amount of day length and they're going to be warm. They have a similarity to their day. The angle of incidence is the angle at which the sun's rays strike the earth. One way to understand what this means is to think about a flashlight. Shine a flashlight directly overhead at the sidewalk, at grass, or at a piece of paper. You'll notice that the area that it covers is very small and more concentrated. Now, say you take that flashlight and you angle it. Where that light hits your paper or hits the sidewalk is going to spread out. So, for example, this flashlight that I'm highlighting right here is the relationship between the sun and the earth around the equator. The in and around the equator receives the most concentrated amount of the sun's energy. Well, if you live at higher latitudes, the angle that the sun hits, because we are a curved surface, is never going to be direct. And so, therefore, the sun's energy is more spread out and it's not as concentrated. There's a direct relationship between this angle and the amount of solar radiation that actually reaches the ground. Therefore, throughout the year, the angle of the sun's rays they're low at the poles compared to those close to the equator. As a result, insolation at the poles is spread out. So, for example, if you take a look at table 3.1, in this column, you're going to notice the latitude. Then we're going to have, remember these 4 important dates that the sun and the earth hang out for coffee. 2 of them are equinoxes, and remember equinox meaning equal. And then we have solstice, 2 solstice. The March equinox and the September equinox represent dates when the sun is out the same amount of time for everywhere on Earth. The June solstice is for when the northern hemisphere is pointed toward the sun. The December solstice is going to be for the northern hemisphere when we are angled away from the sun. So if you live at 90 degrees north latitude, which is the Arctic Circle, the angle that you're going to be receiving of the sun at the March equinox is 0, the September equinox is 0, and the December solstice is 0. Now, during this June solstice, you're going to receive, remember, because we're in the northern hemisphere right now, this is when the June solstice, when up in the Arctic Circle, they receive actual 24 hours of sun. This is when 24 hours of sun starts for them. But look, the angle is very, very low. So let's go to where the Arctic Circle starts, the North Arctic Circle, which is 66.5 degrees north. Here is the angle that the sun will sit at these various dates. So again, in the northern hemisphere, receives the highest amount of angle of the sun, most concentrated during that June solstice. Well, let's go now to the Tropic of Cancer at 23.5 degrees north. When is the sun going to be at the highest, most direct angle? Again, it's going to be that June solstice. This is when everywhere around the Tropic of Cancer is going to receive the sun right over your head, which is directly over your head at 90 degrees. Let's go to 0 degrees latitude, which is the equator. Now, take a look at this one. During the March and the September equinox, at the equator, the sun is overhead. Then at the June and the December solstice at the equator, the angle is still very, very high. So if you look at in and around the equator, these are high angles, which mean the sun is going to be giving the most concentrated amount of sun. And then as we go into the southern hemisphere, we're going to see this pattern repeat. We're going to notice the opposite of the northern hemisphere. So you're going to notice that into the December solstice, the southern hemisphere, this is when their summer starts. And this is where in the South Pole at 90 degrees south, the December solstice is when the southern hemisphere is going to start their 24 hours of sun and when they actually receive it's not a very high angle, but it's something. The amount of sunlight that strikes the Earth's surface in 1 hour is half enough to handle the entire world's energy consumption for a full year. The Earth is our battery. The Earth is the energy. It makes life on Earth possible. Yes, it grows our food, but it also creates weather. It makes precipitation possible. What makes precipitation possible? Evaporation. The sun heats up water, it turns into a gas, it goes into the atmosphere, and it becomes rain. The earth also makes wind possible. The earth makes weather possible. The earth moves the clouds, the sun moves the clouds, the sun creates evaporation, the sun's energy powers the wind and brings rain. So without the sun, rain would not happen. Water, for us as humans, we would run out. The other important part of the relationship between the earth and the sun is the amount of day that we receive. And day length, as we've realized, is going to vary for different places on earth. Now, the dates that we have selected down here were chosen at random. They do not align with a solstice or equinox. The reason why it's important to use dates for examples that don't is because we've already outlined what happens during these times. So let's talk about how long the sun is out, different locations on the earth during different days. So let's go to Tokyo, Japan, which is at 35 degrees north in the northern hemisphere. How long is the sun out in Tokyo, Japan? Well, on February 16th, it's out for 10 and 3/4 hours. Whoa, and during the summer, It's out for 13. That's about right. February is winter, August is summer. Now let's go to a place that's in the southern hemisphere that's almost the same amount of latitude below, right? So 35 degrees south latitude in Australia. And you're going to see the exact opposite. On February 16th in Australia, they're going to have 13 and a quarter hours that the sun is out. After all, this is southern hemisphere summer. Now in August, this is southern hemisphere winter. So the days are going to be shorter. The sun is only out for 10 hours. This means that majority of the time in Australia during August, the sun is going to be down for a majority of the day, right? If we have 24 hours in a day and we divide that in half, it's 12 and 12. So in winter, Australia is only receiving about 10.6, so about 10 and a half hours of day length. So the sun is mostly down during their August, which is winter. So in the lab, you're going to be looking at some of these and explaining some of what you see. So, for example, I've outlined this example for you, which is Canberra and Tokyo are both located at a general latitude of 35 degrees. One is 35 degrees north and one is 35 degrees south. What are the differences and what do you notice? So, as always with any lab, if there's anything here that doesn't sit well with you, don't worry about it. Learning is about not understanding and trying to understand. When I was in college, I had to go through my lectures 2 and 3 times. And when we're learning, we mess up, we make mistakes. And so that's one of the big reasons that I want to make sure that when you turn in your labs, you have the opportunity to correct them. And I sincerely hope that you do. I love to meet with you. So once you have learned this and you've practiced, check in with me to let me know how you're feeling about this topic. I would love to meet with you and review and teach more of this. I'll talk to you soon.